Okay, example 1A. I'm going to show with with both methods. So let's see if we can get. All right, so here's the hint. All right, anything that you think is the most complicated part of the integral is typically what you would want to call u. So and the part inside. So if I think that we were dealing with this exponent as far as the derivative goes, then it would be very wise to call u x squared plus 1. Okay. Now check this out. So here's the thing then. So if I want to take the derivative of both sides with respect to x, so in other words, I'm going to say du dx, okay, this would equal 2x, right? But we're wanting to get rid of multiple parts of this. So let's say then that du is equal to 2x dx multiplying both sides by dx. Okay. All right, cool. All right, so then, so we should be able to make some substitutions then. All right, so right here, I can see that this is du, and this is u to the second power. So here's my substitutions. So I'm going to go the integral of u squared, and all of that was du. That works out really nice. So that's du. All right, and so now here we'll go ahead and take this antiderivative with respect to u now, and that will be 1/3 u to the third power plus an unknown constant. But we started off not with u, we created u ourselves. So we just go back and we substitute in, and so u was equal to x squared plus 1. So we have x squared plus 1 cubed plus c. Yay, good. And we're done. Now, but let's take a moment and try this a different way with pattern recognition. Did the chain rule occurred? Did the chain rule occur? Yeah, the derivative of the inside is sitting right there. Okay, so if this came from x squared plus 1 to the third, if that's what we think happened, then the chain rule happened, and so everything's good. So this part right here was the chain rule happening for us, and so we can just immediately go backwards. So it is going to be 1/3 x squared plus 1 to the third plus c. Now you're like, well, what in the world's going on there? Well, the chain rule, since it occurred, I was able to go backwards, and so when you're going backwards, this part right here just kind of disappears because it was created by the derivative. Okay. All right. So that's it for 1A.